I presume you can all hear me now. 1, 2. So it's really great. I actually can't see a single thing in here. So I'm talking to an empty room right now, but I can hear you all, which is great. So if you get angry with me, any point in the talk, just throw something, because big target. So this is a talk about intentional code and intentionality and minimalism. And really, this is a response to that sentiment that you kind of feel when you look at software that you maintain and think that everything just kind of sucks. Like, everything kind of sucks. So what we're going to do here, we're not really going to look at too much code, but we're going to feel things. So if you don't like feeling things, you're going to have a bad time. So we've all been there, right? We've opened up a piece of software, we've tried to edit a thing, and we've been like, what is this? What is this thing I'm looking at? Where's all the stuff? I don't understand this. Why would anyone do this thing like this? I think it's like the normal reaction most people have to foreign code bases. And I want to talk to you about why I think we feel that way. So all about feeling. So my name's David, and I spend way too much time thinking about software design. It's basically my toxic trait. I'm the head of architecture for a company called New Day in London. Yes, we're hiring, whatever. They love it when I do that. I spent about a decade as an independent consultant, but I'm really here to talk about why design is important and why every single thing matters. I'm a programmer at heart, and you're going to pry my keyboard from my cold, dead hands, regardless of the job title that you stick on top of it. So that said, there's not going to be an awful lot of code in this talk, because what I really want us to think about is design, and design is a very, very distinct thing. So I did a small bit of a viral tweet. Anyone else have a hit tweet? That seemed to resonate pretty well with people. And I was trying to fix up this objectively awful, awful code base. And I opened it, and my heckles were completely raised by this god-awful organizational pattern, this horrible thing. So I did what I always do when I get mad, and I started rage tweeting into the void. And I distinctly remember thinking, like, this is a damning indictment on the state of modern application design. And Twitter obviously agreed with me. Great, thank you, mostly. But the thing that really jumped out at me from this particularly shitty code base was how thoughtless all this stuff is, how completely thoughtless it was. Organization by architectural feature is way up there on the list of shitty things you can do to your software that has no real meaning. Precisely because there's no answer to the question, why is this like this? And that's the thing that's just kind of screaming in my head. Why is it like this? So hopefully, throughout this session, we're going to cover ways that you can answer that particular question, why, in the software that you build. And as the joke goes, organizing your code by architectural concept is about as meaningful as taking your classic car collection and organizing it by wheels, windshields, windscreen wipers, and chassis. It ceases to be about anything. It's not about cars anymore. It's just parts. And a lot of the software that we see today looks like parts to me. Now, so much of this talk about design and the form of code always ends up being dragged back to work in the 1990s that was mostly about design patterns. Okay? So this isn't a talk about design patterns, very explicitly. But what I do want to do is pay them a little bit of lip service and due respect before we get going, because it might perhaps be easy to misinterpret what I'm about to say as a tirade against design patterns, and or like a rallying cry against standards, but it really isn't that. Design patterns, if we don't know, they originated in the works of Christopher Alexander, who was like an actual real-life building architect, like a real one that the job title was invented for. He wrote this work with this beautiful title, which is Notes on the Synthesis of Form. And it was consumed by a bunch of computer science researchers throughout the 70s and 80s. And in the end, that resulted in the kind of, the works by Kent Beck and Ward Cunningham in the late 80s around pattern languages. Now, the Gang of Four book here, which is the one that most people have heard of, this came out in 1994, which is probably about as old as the average attendee at this conference at this point in time. It was probably really the foundational text around design patterns. And what it did was it attempted to lay out a series of structural, creational, and behavioral patterns observed in common software of the era and at the time. So there was a bunch of noteworthy stuff around design patterns that followed. People like Kent Beck wrote Smalltalk, Best Practices and Patterns, which again ages it because Smalltalk was still relevant. Martin Fowler wrote the fairly famous Patterns of Enterprise Architecture. But ultimately, the intention of all of those books was both good, and it targeted one specific thing: to provide concrete guidance and descriptions of common solutions to common problems, describing things that we saw all the time. And that's what design patterns really were. They're giving names to model answers to common questions. And when you really give concepts names, you empower them, and you can talk about them, and you can discuss them. And I have nothing but respect for the people that put the foundational effort into giving things names that we see in our industry, especially when it was very, very young. But this talk isn't about that. Patterns try to make categories of problems that look the same. This is a talk about everything that isn't the same in your software. Now, I suppose I just kind of lament that most talk of design and software kind of devolved into this talk of design patterns because they're the least interesting part. If design patterns are about all the parts of the systems that you build that are familiar to you, then we have to accept that as we push programming languages to innovate, we should be making these design patterns obsolete over time. And we see this in programming languages all the time. It kind of feels like we forgot to have a conversation about everything that wasn't predictable or common. And because that's where design, real design, actually starts, where talks of patterns end. And you're just left with trying to work out how to find form for the rest of your software. Now, on the other end of the spectrum, we have large-scale architectural conversations. Okay, so we have conversations about things like n-tier architecture, hexagonal architectures, and stuff like 12-factor apps, which all try and offer prescriptive rules or characteristics around the form of an application. But I think software design has more axes than just functional patterns and large-scale architecture. And I think the most interesting aspects of design, the ones that really affect the way most programmers interact with a system, exist in the gap between those two things. So, funny story. You wouldn't think it, but back in the depths of time, I was an art student, which is why we feel things in here. As in, I literally studied literature and design and fine art and painting in the 90s in high school. I specialized in literature and politics, and I'm currently a programmer. I just always wanted to be a programmer, right? So for the first half of my career, I really struggled to reconcile this aesthetic sensibility of design and computer programming, And I started programming in the mid-90s, where the works I previously mentioned were about design patterns, were kind of the de facto works on software quality. And now, I did a computer science degree, which I didn't particularly enjoy, but that's here nor there. But during the first year of my comp sci degree, I happened across, like many people do, the work that Donald Knuth put together around the art of computer programming. And he'd written a book called Literate Programming way back in 1984, which was literally the year I was born. So much for new ideas, right? Literate programming. Now, Donald Knuth had tried to get traction in this space with the idea that software should be written combining what he called a documentation language and a programming language to produce comprehensible and maintainable code. Now, this is consistent with the rest of Donald Knuth's output, really. This is the guy that wrote TeX, after all. He took a decade out of writing a book to write a tool to write a book in. So it does not surprise me that he was really into this stuff. And if you think about it, the languages that were popular in the 70s when Knuth was formulating this idea of literate programming were far lower level than the programming languages that we have today. Modern programming languages are kind of an order of magnitude more pliable and expressive and, frankly, more irregular in form than they were in the 1960s and 1970s. So Knuth was right, honestly, and programming languages over time trended towards being more literate and looking more like written language. Now, the core of the idea, though, really, really stuck with me for years and years and years. Software really is the same as literature by basically every measure. And we're going to dig into this a little because it was a little bit of a revelation for baby programmer David. And it changed the way that I started writing code, and it's changed the way that I started reading code. Our software only becomes good literature if we design with that in mind. So, over the years, I've come back to this precise definition of what I believe software really is. It's a constrained form of communication between programmer and programmer that describes concepts and problems that also happens to be executable by machine. Now, the more you think about it, the more that starts making sense. You know, you spend a much larger portion of your time reading code than you do writing it. This is a commonly accepted truth. Your code exists in a context. It has subtext. It has authorial intent. Sometimes the implementation contradicts the intent of the author. Your code has flow. It has rhythm. It has form, just like any other writing. And most importantly, your code has reason. It has intent. So this slide now goes in like every talk I ever write. It's funny. Like, be mad at me and burn your copies of clean code. It's aged really poorly. It means we don't have to deal with that guy. It's a dogmatic book that's cast a long shadow over the industry and discussions of quality and design. It's a bunch of silly rules. There is fundamentally quite a thoughtlessness in a book that thinks it can describe a singular way and approach to design software. Thoughtless dogma followed blindly. Get rid of it. Burning pyre. So again, heresy, I hear everybody cry, absolutely heresy. You can't say that about writing clean code. I love writing clean code. There was a point in my career too where I thought that the rules around basic hygiene were enough. And that, you know, over the last 5 or so years, what I've actually come to value is this idea of intentionality in my code above any sense of syntactic cleanliness. And, you know, I hear people saying, well, what does that even mean? But what it really means to me is that every single character matters. Every single thing that you write in your code. And I want you to approach the work as if every single character is important. The white space matters. The rhythm of your code, the naming, the stanzas, the form, the function, are all there to tell the next person that comes to read your body of work something important. Code written with thoughtlessness, with thoughtfulness and with intentionality are what really matter, because if you're working with a code base that people have taken the care to write well, you can feel it. And I want to talk to you about how we're going to feel it a little bit here with some examples. So, thinking of your software as literature lets you kind of value different ways of communicating in code. We can communicate on the macro scale with organizational patterns and application architectures. You know, let's take, for example, a standard MVC app. Now, MVC is an organizational pattern. It dictates how you split up your code bases. And in all of its common implementations, it tells you how to organize your application. I've often talked about how I have this kind of love-hate relationship with MVC as an organizational pattern, because what it tends to do is obscure the actual function of the application that's buried inside of it. When you open an MVC code base, what you see is how the code is connected together, not what the function of the application is, always. You can possibly presume it's a website, but what it does is completely opaque to you from the outside. You know, so it's a good example of an organizational pattern that tells you how something works while obscuring intent. Right? That's a choice you can make. It's a trade-off. You know, I actually find the micro scale more interesting, where the way that you form your code from function to function, from module to module, telegraphs intent. Now, we use form and flow to increase cohesion of our code base generally. Like, these are almost classic design skills. Now, by way of example of what I mean when I say use form and flow and cohesion on a micro scale, I want to share 2 screenshots a little bit side by side. So I also recently tweeted these screenshots, and they're from the same application that was organized like a piece of crap at the start. So this is a frankly pretty ugly, benign function that does some HTTP stuff. There's nothing interesting about it. And it's really difficult to read because there's no use of formal flow in these lines of code. It forces your brain to comprehend each line in total isolation. There is so much space here that you're reading in this staccato fashion and having to build up a mental model in your head. So when we're writing, we use paragraphs in text to guide the reader, to group related concepts before moving on to something else. This is kind of writing 101. Code is exactly the same. So lines mean something, and if you use them everywhere or nowhere, you're removing an entire category of expression from your code base. Now, this is like a really incredibly small-scale example that does a great injustice to the effect of code with good form. But code with form is like poetry with rhythm. It directs a reader. It telegraphs how you're meant to read the statements. It shows you what is related by the way you organize the statements. Its aesthetic sensibility reflects how the flow control in the software is designed to be interpreted. And all we did was delete a few lines and group a few things together, right? And actually, there's a huge improvement there on a very, very small scale. The flow and form of your code is something that you use to communicate your intent, something that is often lost in the morass of kind of linters and auto-formatters and regular form. Form is intent, form is important, and it's design. Now, the more I started thinking about software through this lens of literature, through this lens of intent, the more it became apparent to me that what I was really reacting to was the inherent complexity of a lot of modern software, right? And what I was doing is I was craving clear communication of well-written prose. I was craving this kind of meaningful, thoughtful, intentful code. And really what it was doing is it was representing this grander design problem. And this is good, I've been working on a sentence recently for the past couple of years. Yeah, a sentence, great. Ridiculous to be working on a sentence. But I think this describes this kind of intersection between complexity in modern software. And it's exactly this. The complexity of your application should be at most as complex as the problem space it inhabits and no greater. This is my golden rule of design and how to tell when you are over or under-designing something. Making sure software is the right size is an aspect of form. Brevity is an aspect of writing. So macro and micro design are the tools we use to meet this goal. Now, so many systems that just kind of straight up fail this test, right? They lose themselves under infrastructure and build systems and deployment and modules and reuse and like all of these grand ideas about the eventual destination of a code base without really focusing on what the correct form to express the problem they have right now is. And this is the same sentiment you find when you look at, rules like Yagni, you ain't going to need it, right? It's a rallying cry against over-design. It buries systems. It makes working with those kinds of code bases like swimming through treacle. And it's like we forgot how to build small things while swept away by fantasizing about building like the next mega-scale metaverse AI monstrosity. And like I think what makes software beautiful is what makes it really shine is when you build these beautiful small pieces of code that solve really discrete problems. Right? That's why I got into this. It's like puzzles. It's fun. Now, the interesting thing about thinking about software design, and even using the word design in this context is often a little bit contentious because design is a word that exists elsewhere in the world. It means a lot of things and it's easy to mistake. So design exists to solve a problem, to communicate intent using form and function. That's the purpose of design. But design is also temporal in nature. And with many designs only really making sense within their context, even if great design can be described as timeless. Now, even when you look at the outside of software, great design is deeply contextual. So we've got some examples here of what you could argue are pretty great designs, like iconic designs. Now, these are very, very explicitly period designs that actually are nonsense now because we remove them from their context and they don't really make any sense to kids born today, right? And, a lot of our legacy expressions of design and software fail in a similar manner, actually. And we have a lot of, despite being a young industry, we've got a lot of design that just doesn't really make sense in the context that we operate today. Now, there's also another really interesting observation here when we take these two iconic designs as an example, that they weren't actually the last of their lines like most people think they were. They've evolved and changed over time. Now, that's because design is iterative, right? Phones didn't cease, Walkmans didn't vanish, they were iterated out to touch phones and mobile phones and to Discmans and iPods. Now, there's an irony here, of course, if anyone's noticed it, which is these two designs actually converged, right? Actually, what happened is they were both solving the problem of transmitting audio, not playing music or making phone calls. And it just took the context to shift and times to change for them to both get there. Now, I think that's like an inherent evolutionary process that exists in great design. And it's kind of exactly the same reason that a discipline like TDD getting casted as a design discipline is a good thing. right? Because what you're really doing is you're going through that same iterative design process very, very quickly. You know, I'm sure you'll have probably seen the rising trend in kind of people criticizing TDD despite clearly never having actually done it, right? Really, really obviously never having done it. Because many of the folks who have been criticizing TDD without doing the practice have clearly never got that benefit of iterative design, and they clearly just write a test and stop and write a test and stop and write a test and stop. And they're cutting themselves off to a whole sphere of influence by doing that. I think this also highlights one of the other really magic qualities of design as a discipline, which is that it's just as much about form as it is about function. You know, these are entire categories of problems that unless you're clearly a smarter person than I am, you can't really see until you see them in person. Like a discipline like TDD shows you by example the constraints that your system operates under, because you build the thing and you look at the thing and you change the thing. And I don't know about you all, but I can't conceive of problems that don't exist yet until I've got there, right? I think, you know, giving ourselves good processes is better than thinking we can just think so hard about a problem that we can solve it. So I appreciate that the common trope is that many programmers just don't feel like they are visual people. So when I say programming is design, people are like, oh, well, you know, I'm not really very arty. Art is a completely different thing. Art and design are two separate disciplines. You know, I don't think it's categorically impossible to do great design without workflows like TDD, but I know you make it harder for yourself if you try, right? Simple as that. So looking at this as like a framing device and looking at software design as design, it's probably worth us thinking about the context that modern software exists in and how that might challenge some of our more classical works on what good looks like. So it's worth us reevaluating some of the organizational patterns that we have, for example, for modern software in a world where we're not building desktop software anymore. And, you know, I know some people are building desktop software, but most of you aren't. Where programming languages have made categories of design patterns obsolete. Now, I'll tell you what the 10th generation clean architecture folks absolutely hate me for talking about. Most of the things you think of as best practice are probably just overblown structural design patterns. That's it. And they look as ridiculous as the comedy organized by architectural concept patterns that we opened up with. You know, there's often a truism when I work with people that report to me, where they think there's this one great design that we're working towards, and there's this beautiful piece of irony that there are no good designs, there are just constraints, and the only way I can tell if your design is wrong is if you think it's the only good design, because if you think you got the only good design, I can tell you you're wrong, right? And the irony is really not lost on me. So I see a lot of system designs these days that have been fragmented into kind of microservices. Who am I kidding? It's like 80% distributed monoliths, but let's not worry about that. But then the individual moving parts of these systems have been absolutely decimated by best practice, right? Absolutely destroyed. You know, the overall picture looks fine from 50,000 feet, but as soon as you get into the detail, everything just feels wrong. Like the application design patterns overwhelm the scope of these individual tiny moving components. And I want to show you an example based on an application that I was working my way through with a team recently to see this really writ large on a system. Now, you don't actually have to worry about what it says. I know you can't read it. But it's a class diagram I generated from a system that was following this kind of prescriptive, clean architectural design. But all I see here are just telltale signs of thoughtlessness. Now, this system, which was in the process of being recomposed back into a single logical application, was divided into a huge number of modules, all of which were further subdivided by architectural feature. Each part of the application was its own mini web application, depending on the subsequent modules project, which contained the logic, all coupled together with a shared common library underneath. And the total cognitive load of understanding the scope of change in any one of these things was just huge, absolutely huge. You could not tell if you were in the left-hand side of the system if you really needed to worry about the right hand of the system at all. And, you know, some would describe this as really well-intentioned. You know, we've subdivided all our concerns down well. All I see here is an explosion in complexity. It's a simple problem with too many moving parts. And, you know, what we've really done is we've taken the surface area of the software and we've spread it out. And the funniest thing is, all this stuff was maintained by a single team of 3 people. right? And I just looked at them, and they were drowning under the complexity of build pipelines for all these individual pieces that they built. Now, for all of this macro design and project structure and organization that was forced upon the project, the actual state of the design of the code itself was awful. It was this junk. And again, you don't really have to pay close attention. Like, it was shockingly low quality. The state of the actual code, so this is a diff between where we started and after we finished kind of cleaning it up and took away all the boring, repetitive, cross-cutting infrastructure that was in everything. All of this effort was focused on organization and none of it on the actual work, right? And I thought that was just a tragedy. It was rot. So this was a classic case of people focusing on macro design. In this case, you must always have this set of projects for every single thing we build, and totally neglecting actual application design. And I see this all the time. Like, I'm sure you've all got systems like this, right? With like 38 projects that all compile down to a single logical web application that's deployed in like a function app. Right, it's just one thing. So how did we spot this and fix it? What was the tell? How did we know that this was a problem? Well, we first did like a first round trim of all the complexity. So we collapsed all the modules up into each other and rolled them into each corresponding web application. A pro tip, you might think you need assemblies and DLLs and packages for things. You just use directories. Directories are great, as old as time, would recommend. So rather than this web application depending on modules to do work, they at least now were responsible for their own capabilities. We preferred cohesion and co-location, so bringing things that work together, over slavishly trying to split and distribute knowledge around the application. And then finally, once we had rationalized the code base into a series of applications, and their behavior was then compiled and collapsed together, co-located and deployed together. Now, we realized that the correct course of action was just to take all those applications and smush them into one. And at the end of it, we ended up with a single logical program with about 30 APIs in the thing, and that was it. And you might think, oh God, 30 APIs, what a monolith. They all did the same kind of stuff, right? The same category of behaviors. So it made sense because it was easier for a team of 3 people to wrangle with a code base with a smaller surface area. The design had more meaning and was done for a purpose, rather than just following a rule. Now, after this was all completed, we ended up refactoring 64 modules and 19 build pipelines times 3 environments into 3 things. And then we could fix it, because then people could refactor and all their tools worked better and everything kind of hung together. And this is what adhering to structural design patterns over actually thoughtfully considering your code gets you, right? This is your clean architecture writ large on a real system and the explosion of infrastructure that comes at a cost with it. Like, please build smaller things. Smaller things, fewer moving parts always are better. Now, there are obviously some known good designs, right? There are certain problem spaces where there are structural patterns that represent systems that we build all the time. So the most glaringly obvious examples are things like, RPC-style systems like HTTP APIs often map quite commonly onto command and query patterns, right? Very, very obvious organizational patterns. But in those systems where there are known good answers, your application's form and flow matters even more, because what happens is everything starts to look the same and repetitive. I suppose what I'm reaching for here, and it's not just what you say, but it's how you say it, right? If we take this back to literature. And it matters because when your macro design is comfortable, then the risk of code blindness and skim reading increases. And when you're trying to maintain a code base, you will just start focusing out and zoning out and skimming past stuff. So, in fact, one of these kind of core problems with known good reference designs is that it's easy to learn a design pattern or two and kind of decide that everything in software needs to look the same, right? Really, really easy. And I don't know how many other people have been here, but like, this is my entire career that I've had to spend learning this lesson. Like, at various points, maybe you recognize some of these situations. I learned about MVC and I thought everything had to be a controller. I did that. That was me. When I first learned about aspect-oriented programming, all I could see was chains of interceptors. When I was told that controllers were only ever about HTTP, I thought everything was an application service. When microservice design first got popular, I thought everything had to be completely decomposed. These are all mistakes I made by learning one thing and trying to apply it to every single context. I made them all, right? I made them all. And it takes some time to learn that uniformity is the opposite of expressiveness. Completely the opposite. It's important that when different parts of your software do something different, that their form reflects their function, and they don't look the same. We don't want them to look the same as everything else. The visual variation leads the eye, it encourages reading instead of skimming, and it removes these large blocks of identical pattern text that you see in code everywhere. So this is really secretly about a war on complexity, right? And a war on finding a language and describing something. We need to stop doing things just because, and we need to stop cargo culting design decisions. But if you don't understand why you're doing something, you should always stop doing it. It sounds really simple. It's the Chesterton's fence example, right? Which is, I always like to talk to my teams about this. If someone comes up to me and says, "Hey, David, there's a fence in the middle of the road, I want to knock it down," the answer should always be no, right? The answer is, unless you can explain to me why the fence was put up there in the first place and what the original author was trying to achieve, you shouldn't remove it. Only when you understand it, you can remove something, right? So not understanding decisions is just as bad as that. So unfortunately, because so much of software is context sensitive, there are many times where blindly applying design patterns makes software more difficult to reason with. And what that does is it increases the cognitive load of understanding what a program does. And this idea of cognitive load is kind of a good quality metric to think about. Our job when designing software is fundamentally this war with complexity. So when I talk to people about complexity, I'm often a little bit shocked about the things that people do not recognize as complex in software. So there's this really great book called A Philosophy of Software Design. And I always hate being on camera when I say this guy's name in case I mispronounce it. John K. Oosterhout, I believe. And I think it really gets to the heart of why complexity is a problem. I'd really recommend the book, by the way, and its second chapter is all about complexity in design. It's the central theme. And the theme is that complexity is never caused by a single catastrophic error. It's the tiny paper cuts of complexity that accumulate over time. So it's from the collection of dependencies, it's from obscurities and idiosyncrasies that are at work. Oosterhout describes complexity as the thing that leads to change amplification, high cognitive load, and unknown unknowns. And that leads to an explosion of work and effort and the number of modifications it takes to build each additional feature. So building on that definition, I think intentional and thoughtful design is this kind of salve for the creeping wave of complexity that surrounds software everywhere. There's this distressing realization, okay, when you reach these lines of thinking. Design patterns are precisely so popular because it gives people a way to reach towards a thing that they feel is good. Right? There's always an answer that they've reached, a definite conclusion. That, like the comfort in design patterns is, I've done the right thing. This is what I learned. This is the right answer. I can feel good about myself. But once you've seen enough code bases in enough languages, you kind of realize that most of the arbitrary stylistic qualities of code that people often focus on, tabs versus spaces, brace style, are basically irrelevant. Like totally irrelevant. And instead, there are a couple of non-negotiable qualities that you look for in a code base that are far less regimented than your average JavaScript style guide, right? So, good code is code that's easy for someone with minimal domain context to read. It's code that your average developer can understand. That is good code. Good code is code that focuses on developer experience, debuggability, and usability. Code that you cannot debug meaningfully is not good code, fundamentally. And code where the intent takes up more of the visual space than the language syntax. So code where you can see what it does at a glance when you try and sight read it, over seeing how it does it and the flow control of the language, is good code. Code that buries what it does under a programming language is ugly and intractable. regardless of language or style or intent, all programmers basically interact with code bases in the same way. They glance at it to understand what it does, and then they read intently to understand how it does it. So it's always this kind of two-phase, what is this, how? What is this, how? Good code, regardless of style, regardless of language, regardless of framework, makes that core behavior really, really easy. And, you know, at this meta level, all code is constructed from a series of abstractions and encapsulations. That's kind of what we have. So what we have to do is care about the costs that these abstractions bring. The programming languages, runtimes, and frameworks which write higher level code go through an enormous amount of compilation, translation, interpretation to execute, right? We know this. We know that we're building on these stacks of software all the way down. Now, programming languages themselves are common abstractions over operating system APIs, for example, which are abstractions over assembly languages to microarchitectures, which are abstractions over physical hardware. So there's always a bigger abstraction underneath. You always remember that. This trend kind of continues upwards, though, to the functions that you write and the types that you define and the classes and files that you create that make up your application are all examples of both abstraction and encapsulation in action, these two things that you have. Now, for the most part, we're kind of blissfully unaware of this huge amount of complexity that exists under our programming environments. And that's because the value that the abstractions underneath us bring vastly outweigh the complexity of comprehending them, right? Great abstractions vastly outweigh their complexity. That's kind of the good bit. And now you now have to worry about all the stuff that happens when you call file open, is my favorite example. Right, file open is like a horrendously complex, deep abstraction over operating system APIs and physical disks and SSDs and God knows what, right? File systems. But what file open does and file system APIs do is they reduce the cognitive load on the developer, always. They completely encapsulate complexity. Now, if you implement your own software, sadly, it's not always the truth that the abstractions that you introduce reduce the complexity on the reader. Right? I only wish everything was as good as a file system abstraction. So it's important that we understand how abstractions both increase and decrease complexity. Now, I'm going to borrow a little bit more of the terminology from Oosterhout's book when we think about this example of file open. Now, if you think about a module in a piece of software, this could be a package or a class or a binary. Its interface represents the complexity that that module imposes on the rest of the application, the rest of the system. The smaller and simpler the interface that it exposes, the less complexity it forces onto the code that consumes it. By that description, you can think of the best modules as deep modules, which offer a large benefit to the application for the simplest possible interface and the narrowest possible definitions. Right? Simple as that. The inverse is also then true. An interface with lots of functions and lots of parameters and a relatively meager set of benefits forces the consuming application to knowingly choose which parts of it you're going to use, right? So what you're actually doing is exploding the space of possibilities by importing that module. So you're significantly increasing the cognitive load on an application by broad, shallow interfaces. So I think when we're designing, it's important to keep that thing in mind that, you know, if you have lots of broad and shallow interfaces, you're actively making the design of your software worse, always. Now, as much a factor of avoiding the wrong abstractions is also, you know, how you find the right ones. And, you know, it may seem like painfully obvious advice, but abstractions and, you know, generally any other module or of code that you find should contain a problem space in its entirety, right? And like the number of code bases that I see in most businesses that just do not comprehend that these are the things that we're doing when we're designing types. Like we're trying to contain knowledge is quite significant. I'd say most systems, right? Dangerous. Now, so there's things, abstractions that are things like pass-through methods. You know, as soon as you design a class with a pass-through method, you're adding no value and introducing an abstraction. Instantly increase the cognitive load of a system, right? Data types and abstractions that operate on the same data types that they expose, almost by definition, are not abstracting anything. You're exposed to the same core types and data structures that you're exposing from the top. Then actually, I mean, what are you doing? It's really just a function. That's not an abstraction, right? So you fail if you You don't describe problem spaces coherently. Our software is riddled with this kind of thoughtless abstraction and poor encapsulation. And every time a design decision like that is made, it decreases the reasons that a module exists at all, or that piece of the software exists at all. Anything that adds a large amount of boilerplate code for a low amount of utility is by definition thoughtless design. Now, you get to a certain point where you realize that all talk about design often kind of dissolves into this kind of discussion of dogma and absolutism, because there's an absolute truth here. And I kind of hinted at it before. Any design, when stretched to its logical, absolute extreme, becomes nonsense. Right? Any design at all. Designing software with intent, software that survives, is an exercise in compromise and trade-offs. It's why everyone with any experience in designing software that's been used by real people will pretty much just say it depends whenever you ask them anything. This is the kind of the it depends as a service talk. Every design challenge is an it depends answer until the layers of detail are peeled back and the correct constraints are discovered. And most good design comes from starting off in a very, very open room and applying constraints until the design emerges. A lot of the talk about poor trade-offs I see in software involves people actively not understanding the sources of complexity in their system and the weird design in their software, doing things like taking additional dependencies like packages and services for single, simple use cases without realizing that the cognitive load of adding those extra dependencies and the associated management of them and the kind of API explosion that they introduce is sometimes more expensive than just doing a thing themselves. There's a lot to be said about the lower risk of maintaining 30 lines of your own code than adopting something you might otherwise get for free, but then have to control versioning and all this kind of extra stuff that you don't understand that is owned by somebody else, right? So there's this healthy tension between doing your own thing and reusing stuff just because it's easy. It's interesting because, that sentiment is a really uneasy bedfellow with the concept that every line of code that you write is a burden, right? And this is a complete truism. You write a line of code, you're maintaining it, you own it. It's cost. The best amount of code you can probably get away with writing is no code at all, and everything else is expensive. But at the same time, this is true for every line of code that you adopt. You adopt a line of code, you may as well be owning it. It's like a puppy, honestly. Something more constrained with a smaller surface area pushes less complexity into your applications. Now, that's really the thing, really. The available potential surface area of the code you have is where complexity flows from, right? As a practical example, I recently wrote 200 lines of a program instead of using some static site generation framework because I Googled stuff for 3 hours and found all the experimental bits, and I just, I can glue together some markdown files. It's fine. It was easier for me to write a 300-line program than understand the documentation of something that was in constant state of flux. So I think that kind of thing is real, and it's a real tension in all of our software. Now, all your designs should be expressions of these kinds of trade-offs and compromises and gentle balance, rather than a single idea, layout, or concept dragged into its natural position of surdity, like use open source for things we get for free because it's cheaper. Not always. Use MVC for everything that talks to the internet other than APIs, right? Everything is constraints. You've always got to understand why. Now, in fact, once you start considering things as this kind of sense of a continual trade-off, what you realize is instead of rules around system design, what you really do is you end up with kind of tests and properties. Now, I don't mean coded tests, but tests with which to evaluate the qualities of a design that help you choose the kind of system that you're going to build. I want to take you through a few tests that I use to evaluate a good design so that hopefully you can look at your choices from a different perspective or come up with your own kind of tests. Could this be done with less moving parts? And this is kind of, I suppose, controversial in the world of poorly implemented microservices. But I tend to find if you can do more with less moving things, the combined complexity that you impose on your system is reduced. You know, additional moving parts, repositories, packages, dependencies, functions, microservices, should only be added when the total cost of maintaining them and all of their associated build pipelines and tests and SAST and DAS scanning and whatever else you have to do is lower than a localized solution to the problem, right? And that stuff is very, very big most of the time. There are many places in our ecosystems where ballooning complexity makes working with our systems more complex than it should be. We should never just extract out parts of our application because it looks nice, right? Not a good enough reason. Break up systems into individual components only when they need to ship, scale, deploy, or fit more humans around them independently. Is this operable in a production environment? Similarly, software systems that are hard to observe, deploy, manage, and automate slow the pace of change. Right? We should always prefer software that can be trivially managed in production that reduces our operational burden where possible. Software that's built with maintenance and observability in is fundamentally better than software that isn't. Software where the design is difficult to configure or deploy, well, that's cumbersome, it's bad design. And is this easy to change? Now, this is the single truism of software in the 2020s. I can guarantee you will be changing your software. So the best quality of your software is software you can change easily. Simple as that. Because we should avoid over-design and focus on simplicity first, especially, we require designs to be easier to modify than the premature optimization of extensible designs that never get extended. You know, it's the old adage of, you know, if you're building systems incrementally, you want to build a skateboard, then a bike, then a car, not a chassis that doesn't go anywhere, then put a seat on it and eventually put 4 wheels on it, right? Software that you can change is always better. So I guess what I'm really talking about again, and at the end of the day, is just putting the design back in software and putting this thoughtfulness around form back into software. I just want you to write your software with care and with purpose. I like to joke you should write your software like you're writing it for someone you're totally in love with, right? Like totally besotted with, because we feel things. I want you to think about the design of your software. I want you to think about the reader. I want you to think about what the form and flow of your applications tell them, because you're always telling them something. I want you to use all of those forms of expression available to you in your code bases to communicate meaning and intent. And I want you to remember that different problem spaces and different solutions require different aesthetic viewpoints. And we should embrace that. Like, that's great, that's wonderful. Lest we damn ourselves to literally everything either being a jumble of components and HTTP calls or an MVC app, because those are the two designs, right? That's basically it. It doesn't have to be that way. And when you use form and design to telegraph intent, the work becomes better because your care shows. Like, I can really tell when people have taken the time. Now, I was on a podcast a couple of years ago, and at the end of like this hour and a half, they hit me with that classic question of like, oh, what advice would you give to yourself 20 years ago at the start of your career? And I know the answer now completely. Take more time. Fuck the deadlines. Take more time. All of the best design work, all the best implementation I do now, I'll tell you what I do. I finish writing whatever code I'm writing, I put some music on, I pour a drink, and I just read it. And I read it again and again and again, and I scrutinize every single line. And I just think, why did I do it that way? Why did I make those choices? Because if I can't justify it to myself in the nice, quiet, late night where I'm sitting there reading my own work, I have no expectation that anybody else will understand the software afterwards, right? Take more time, 20% more time. You know, the software that's right when you deliver it will be better than when it's broken, right? It's just, it's kind of zen and kind of chill. Put a good album on. I want to leave you with a few reading recommendations of work that I've ripped off liberally in the production of this talk. I don't really think there are many books on this topic. Honestly, I don't think we talk about design very much. But A Philosophy of Software Design by John Oosterhout is brilliant, honestly. Read it, it's so good. Your Code as a Crime Scene by Adam Thornhill. There's a sequel book as well, I forget its name. Was very, very instrumental in the way I was thinking about looking at kind of the body of work and the signals that it produces. And Mark Seaman just put out a really good book called Code That Fits in Your Head. All three of these books offer far more exhaustive examples than I can ever fit in a conference session. And, you know, we should support our community and support our authors. And I figure if I'm going to tell you to burn all your copies of Clean Code, you should replace them with something better, right? All those books are better, way better. Thank you very much. I'm going to say any questions, but I still can't see a single person, so I'm going to have to basically walk over here. Now, oh my God, there's a room full of people. That's vaguely terrifying. Hi, hi. I can't see any hands, so I presume you're all damned into stunned silence. Oh, please.
Not defending clean code, but it was published many years ago.
Yep.
When developers were struggling, maybe it was as an answer for the spaghetti code.
Yep.
Can you think that maybe it served its purpose for that time?
That's a really great comment. So the comment was not defending clean code, but it was published many years ago at a time when developers were struggling fighting spaghetti code. Do we think that maybe it's an artifact of its time that has served its purpose, and that's fundamentally a good thing? I think there are some valuable lessons in clean code, but let me summarize them in 2 sentences. Name your variables well. 1 sentence. Name your functions well. 2 sentences. You know what? Like, I found that book interesting when I first read it when I was a baby dev, and I think it did offer me some value. I think everything from about the 3rd chapter onwards is garbage, though. It's a bunch of like asinine old Java junk, and the second half was wrong at the time, let alone wrong now. Read the first 3 chapters, by all means. Interestingly, though, I think that my biggest criticism of clean code is it actually drives, it doesn't understand the fact that decomposing functions into lots of tiny functions increases the cognitive load on the author rather than reduces it, right? So all of the examples are like, oh, I've took these 2 lines and given them a name. But as soon as you do that, at the call site, you don't know what sins are hidden under those functions. So actually, the cognitive load increases. And I think a lot of like the structural design advice in clean code is bad to harmful. I wouldn't say catastrophic, but like I wouldn't recommend it. And again, I think it's because everything requires its context. But I do think, you know, it is worth saying, you know, articulating that thing. I think at the time clean code was written, there weren't any other books talking about these specific things. And I think that's the place that it serves in like the continuity in the canon of software books. No, just staring at me. It's cool. Thank you so much for coming. I really, really do hope you enjoyed this. The green one's the good one, because then they invite me back. Love you all. See something good.